Hi, my name is Adrian, and I will be covering the introduction for our class project, DDoS attack detection using machine learning. Um, in a landscape where malicious actors continuously seek fresh avenues to exploit individuals and businesses, detection of cyber attacks is key. One such attack that can cause major damage is called a distributed denial of service attack, or DDoS. There have been several research papers looking into how to detect these attacks more efficiently. And while they go about it in different fashions, the ones we chose use machine learning. Machine learning is a branch of artificial intelligence which aims on using data to train a model that gradually increases in accuracy the more data is fed to it. Some employ the use of SNOR, which is an open source intrusion detection system, and others use algorithms like random forest and linear regression. Some projects opt for a hybrid approach, combining these methods for reduced false positives and heightened accuracy. The goal of our project was to train a machine learning program to successfully and accurately detect DDoS attacks. To do this, we employed the use of logistic regression and support vector machines.
Hello all, my name is Vijay, and I'll be giving a brief overview of how we simulated the DDoS attack. So firstly, we set up two virtual machines in Oracle VirtualBox. One of them was the attacker system running Kali Linux, and the other one was the target system running Windows 10. So both the systems were placed into the same subnet, 192.168.100.0, and the IP address of the attacker system was 192.168.100.4, while the IP address of the target system was 192.168.100.5. Connectivity between both the systems was verified using the ping command. Then on the attacker system, we executed the command 192 nmap 192.168.100.5 to obtain a list of all the open ports of the target system. One of the open ports that we detected was TCP 135, which is commonly associated with Microsoft Remote Procedure Call. So we ultimately decided to exploit this open port and subsequently launched a DDoS attack against it using the hping3 command that you see at the bottom. This command essentially sent a high volume of SYN packets with random source IP addresses to port 135 of the target system. Yeah, this image that you see right here just describes all the steps that I've just gone through. And I think about 500,000 packets were sent in just a matter of seconds. And now I'll be giving a brief overview of how we captured the packet details. So on the target system, we ran Wireshark to capture details of all the packets associated with the IP address of the target system, which was 192.168.100.5. So the data captured included normal traffic as well as DDoS traffic. This traffic or this output was then saved as a PCAP file. And we then used a tool called CIC Flow Meter, which is a network traffic analyzer tool similar to Wireshark, to extract the necessary features from the PCAP file and subsequently export them to a CSV file. So these two images just show the steps that I've just described before. The image on the left is a Wireshark capture that shows a high number of SYN packets being sent to port 135 of the target system. And the image on the right shows the CIC flow meter, which was used to convert the PCAP file into a .csv file.
Hello, everyone. My name is Hojat, and I'm going to explain about the dataset, machine learning models that we used, and the code. So the dataset which is widely used is CIC DDoS 2019, which is widely used in the research area, especially in the research in detecting DDoS attack in machine learning methods. This dataset developed by the Canadian Institute for Cybersecurity, and it covers a wide range of benign and common DDoS attack. Okay, the dataset covers two main branches of DDoS attack: reflection-based attack and exploitation-based attack. In the reflection-based attack, one attacker send a packet, and then the reflector send like thousands or millions of packets to the target machine. And on the exploitation-based attack, an attacker used bots to send a lot of packets, scene packets, to the target victim. The process that we did on the data contains the checking for null values, checking for duplicated values, data imbalance, especially for protocol variable. And then after that, we balance the data. We propose two methods, the random oversampling and a smooth. Then reorder the data, try to shuffle random between data to prevent any bias in our network, and then encode the label of the attack. We encode the attack as 0 and benign as 1. Scale the data using min-max scaler, and then try to remove the correlated features, and then use extra tree classifier to find the most important features that we can use in detecting the DDoS attack. The first model is logistic regression, which is a binary form of linear regression. In this model, we use the logistic function and then try to penalize the model for misclassifying instances. The other model is support vector machine, or SVM, which is kind of supervised machine learning algorithm, because we have in here we have sample data which we know the attack and benign users, so we can use the supervised machine learning algorithm. It's widely used in classification and regression tasks and can handle nonlinear decision boundaries. The algorithm tries to minimize the classification errors while considering a soft margin in real-world scenarios. After we simulate, use the SVM and linear regression in our data, the result, the confusion matrix for linear regression and SVM shows that both of them are performing very well on detecting the attack, but SVM has the better result. The second result is that we used the data that we generated using the attack, the simulating DDoS attack by HPing tree. And in here, as you can see, the attack completely detected. Now I'm going to explain the code and the result that we have in the code. So we have two different types of codes. The first one is implemented on DDoS, CIC DDoS 2019. In here, we have a function to install the necessary package, then import the necessary package, import the dataset, as we can see. Then this is the dataset that we have. The number of features are like 78 columns or features we have. Remove the null values and duplicated values in here. In here, we use to balance, use the random sampler to bias the protocol. Then we label the label encoder for the class, which is attack or benign, and make them 0 or 1. 1 is for benign and 0 for attack. Import the model, the min-max scaler, scale the data, find the correlated features and remove them from our data set. Then use the extra tree classifier to find the most important features. As we can see, we have 15 important features: protocol, ACK flag count, and so on. Then in here, we train the logistic regression model and try to save the model. And also we train the SVM model in here, and save the model. because the time that it takes to train a model is large. We need to save the model to use it. And in here, we plot the confusion matrix. For our data set, we have 4 different data. The benign, DDoS, two benign data and 2 DDoS data. We merge the benign one and DDoS one and used it as a test, and merge the benign 2 and DDoS 2 and used it as a train for our model. So, but we have some different feature names in our data set. So we generate a mapping to map the features that we have in our data set to the features that we had in CIC DDoS 2019. Then we train, do the pre-processing and scale the data, train the data set, and train the model, linear regression and SVM, which the result of linear regression and SVM, as we can see, it detects the attack, like 100% of the attack is detected. But for benign, we have some benign users that are detected as attack. And for future work, I think we can, somebody can work on modeling the network, a real-time network DDoS detection by using the mininet and simulate the network and try to implement the code inside the simulated environment to find it applicable in real-time servers. Thank you, everyone.